All right, so today we're really diving deep into the world of railway switches and crossings. We've got excerpts from 15 switches and crossings.pdf,
Yeah.
and trust me, it's way more interesting than it sounds. There's a lot going on.
Yeah. It's there's a surprising amount of like engineering and design that goes into keeping trains moving smoothly on the rails.
Right, like you see trains switching tracks all the time, but have you ever actually stopped to think about how that actually
It's
works?
one of those things you just take for granted.
Totally. And that's what we're talking about today. And to start, I think maybe it's good to clarify what exactly I asked the difference between a switch and a turnout, because
Yeah.
those terms get thrown around a lot and they kind of seem like the same thing, but our source makes a point of saying that they're actually different.
They are different.
Yeah.
So a switch is really just the mechanism that lets the train move from one track to another. It's like the moving part. And the turnout is the whole structure, all the different components together.
So the switch is like a tool and the turnout is the whole workshop.
Exactly. A really good analogy.
Okay. I like that. And what kind of things are we talking about in that workshop? Like, what are the pieces that make up turnout?
Well, I mean, you've got the tracks themselves, obviously.
Right.
You've got the main track and then the diverging track.
Mm.
And our source has this diagram, figure 15.3, that shows all the different parts. And one of the key things is the mathematical point. That's where those two tracks intersect.
Okay, so that's where the train actually decides its fate, which way it's going to go.
Exactly.
Yeah.
Going back from there.
Point of no return. So we've got the tracks, we've got that decision point. What else is going on in there? Because there's all these terms, frog angles, stock rails, switch
Right,
rails.
so the frog angle, that's super important. That's basically the angle between the main track and the diverging track at the point where they cross.
Okay.
So a really sharp angle means a really tight turn, which means the train has to slow way down.
Mm-hmm.
And then you've got the stock rail, which is the fixed rail, and the switch rail is the one that actually moves.
So that's the one that's like directing traffic, so to speak.
Yeah, exactly.
Yeah.
Oh, and then there's the check rail. People don't always think about that one.
Okay, what's so special about the check rail? What does it do?
It's all about safety. You know, when a train's moving through a turnout, there's always a risk of the wheel, like climbing the rail, and that's how derailments happen. The check rail basically stops that from happening.
Wow.
It guides the wheel flange, keeps it from going up and over the rails.
That's like a little backup system just in case.
Yeah, exactly. Better safe than sorry, right?
Totally. So much thought goes into these things I never would have imagined.
Right.
Like it seems so simple when you see it happen, you know? But there are so many different factors to consider.
Yeah, the weight of the train, the speed, even like the condition of the tracks themselves.
And speaking of speed, I noticed the source talks about something called Nadal's formula and how it relates to derailment risks.
Yeah, yeah.
Can you explain what that is?
It's sometimes called the Bodecker and Chartet formula as well. But basically, it's this equation that engineers use to calculate, like how much force is acting on the wheel flange when it goes through the turnout.
Hmm?
Because too much force, and you have a problem.
Oh, so it's like predicting how much stress that wheel flange can take before it like gives out.
Exactly. They even have a critical value, which is zero point 0.8. Anything above that, and it's like, whoa, time to slow down.
Wow. So they really have thought of everything. Okay, so we've talked about, these different components and how they fit together, but what about speed? Like, why do trains always have to slow down so much when they go through a turnout?
One of the biggest things is something called cant.
Can't. Like,
Yeah.
I can't believe this is so complicated.
Right. No, not quite. It's about how much the track tilts. You know, on a curve, they tilt the track so the train leans in.
Oh, right. To counteract that, what is if the centrifugal force?
Yeah, exactly. Without the cant, the train would have to go really slowly around curves.
That makes sense.
Otherwise, it would feel like it's going to tip over.
Yeah. And like you said, it puts a lot of stress on the tracks too, right?
Exactly. And then on top of that, you've got something called, what is it, non-compensated centrifugal acceleration.
Whoa there, slow down. What in the world is that?
Basically, it's that feeling you get when you're in a car and take a really sharp turn
Yeah.
and you get pulled to the side.
Oh, right, right. So, like on a train going through a turnout, too much of that, and people are going to get tossed around.
Exactly. So they have to keep the speeds down to make sure that doesn't happen.
So, it's really a balancing act, speed and safety and all that.
Yeah, for sure. And it all comes back to that radius of curvature we were talking about earlier.
Right, right.
Bigger radius means a gentler curve, which means they can go faster.
So, why don't they just make every turnout have a huge radius?
Yeah, problem solved.
Solve.
Right. Well, in a perfect world, maybe. But the thing is, Those big curves take up a lot of space.
Ah, I see. So you run into problems in, like, cities and stuff.
Exactly. Or like going through mountains and things.
So how do they get around that? How do you make a turnout that doesn't need a ton of space, but can still handle decent speeds?
Well, that's where the switch entry angle comes in.
Okay, and that is...
It's basically the angle that they cut the stock rail at, where it meets the diverging track.
Okay.
So instead of a straight cut, it's at an angle, and that makes the transition into the curve smoother.
So it's like a little design trick to make the most of the space they have.
Exactly. It's pretty cool, actually.
It really is. It's like you never think about all this stuff, but it's going on all around us. And speaking of all this stuff, I'm looking at these diagrams in the source, and man, there are so many different types of turnouts.
Oh, yeah. Tables 15.1 and 15.2, they have a whole bunch of them listed.
So it's not just one size fits all, huh?
Definitely not. It all depends on, the specific situation.
Like what kind of things?
Well, the speed limit on that stretch of track, for one, how much space they have, what kind of trains are using it.
Wow, so it really is kind of a puzzle figuring out which turnout to use where.
Oh, absolutely. It's all about finding the right tool for the job, just like any other kind of engineering.
That makes sense. Okay, so are there any like standout types of turnouts, ones that are particularly interesting or unusual?
Let's see. Well, I always thought the symmetrical turnout was pretty neat.
Symmetrical turnout, what's that?
It's just like it sounds, basically.
Yeah.
Figure 15.6 shows one. Both tracks curve outward in the same way. It makes for a really nice balanced look.
Elegant railway infrastructure? There's a phrase I never thought I'd say.
Right.
Okay, so that's a simple one. What about on the other end of the spectrum? Anything super complicated?
Oh, yeah, definitely. Double slips, for example. Those are pretty wild.
Hubble slips.
Yeah, check out figure 15.11. It's where two tracks cross, and you need to be able to go in any direction.
Whoa, that's a lot of tracks.
Yeah, they're definitely more complex, but super useful, especially for high-speed rail.
So it's like the ultimate railway intersection.
Pretty much. Oh, and then there are track fans.
Track fans, what are those? Like those things that blow air?
No, nothing like that. It's, how do I explain this? Think of it like one track branching out into multiple tracks.
Okay.
Figure 15.14 shows it better than I can explain it.
Oh, I see. So it's like a tree trunk splitting off into branches.
Yeah, exactly. And they use them in like train depots and stuff where they need to sort the trains and get them where they need to go.
So it's all about efficiency, making
Yeah.
the most of the space.
Exactly.
It's like a train sorting machine, sending them off in all different directions.
Yeah, kinda. Which just goes to show, like, how important turnouts really are to the whole railway system. I mean, they make it possible to move trains around efficiently, get them where they need to go, and do it safely, too.
Speaking of which, I was curious about how these turnouts are actually operated. Because the source mentions both manual and automatic systems. Is there actually, like, a person somewhere who flips a giant switch to make this happen?
Well, you're not too far off. There are still some manually operated turnouts out there. You can see one in figure 15.19. It's this whole system of levers and stuff, very old school. But yeah, these days, most turnouts are automatic.
Makes sense.
They're controlled electronically, often by the train dispatcher themselves, actually.
So it's all done remotely. That's wild.
Yeah, pretty much. And it's getting even more advanced. The source even mentions systems that can actually, like, monitor the condition of the turnout, like the distance between the
Oh.
rails, how much wear and tear there is on the frog, things like that.
Wow, so they can spot problems before they even happen.
Exactly. It's all about preventative maintenance, keeping things running smoothly.
That's amazing. So I'm thinking we've talked about where you should put a turnout, but are there places where you don't want to put one? Like, are there any no-go zones?
Yeah, for sure. The source specifically mentions tunnels, bridges, and really sharp curves as places to avoid putting turnouts, if possible.
Yeah, that makes sense. Those are all kind of like high-risk areas anyway, right?
Exactly. You don't want to add any extra complications in those spots.
So it's all about choosing the right tool for the job, or the right turnout, I guess I should say.
Exactly.
Well, we've covered a lot of ground today. It's been really interesting.
It has.
I never would have guessed there was so much to learn about switches and crossings.
Yeah, it's one of those things you just don't think about, but it's all around us. Next time you're on a train, see if you can spot some of this stuff.
Yeah, pay attention to those turnouts. Think about the curves, the angles, all those little details. It's amazing how much engineering goes into something so seemingly simple.
It really is a hidden world.
Well said. All right, that's all the time we have for today's deep dive. But we'll be back soon with more fascinating explorations into the world of engineering and design. Until then, thanks for listening.